A warm welcome to all of you in this lecture 3 on processing of ceramic matrix composites. As you are well aware, in our lecture 1 and lecture 2, we have discussed or outlined the basic aspects of ceramics and ceramic matrix composites. Our focus has been to revise the fundamental aspects of ceramics and then try to outline the differences between the ceramics and the ceramic matrix composites. If you remember, we have seen that how ceramics compare with the metals, and also we have seen that how the ceramics compare with the ceramic matrix composites. It has been noted that ceramic matrix composites provide properties which are not attainable with the monolithic ceramics. We have seen that on addition of reinforcement in the ceramic matrix composites, a host or a lot of properties are improved. One or two to name: fracture toughness and percentage elongation to rupture. So, there are few properties or few mechanical properties which improve on adding the reinforcement in the ceramic matrix. We have seen the mechanical properties of the ceramic matrix composites, although we have not discussed in much detail, but it was highlighted that what are the important mechanical properties of ceramic matrix composites which should be taken into account when we are advocating the use of ceramic matrix composites for certain applications. If you remember, we have seen that we should take care of the tensile and the compressive behavior of CMCs. We should take into account the fracture toughness, the fatigue resistance. Creep is an important property of ceramic matrix composites which should be taken into account. And finally, we have seen the R curve behavior of ceramic matrix composites should be highlighted when we are going to use this particular component or this particular material for a particular component or a product. We have also seen that on incorporation of the fibers into the ceramic matrix, certainly some properties are going to improve, and this incorporation is going to affect the fracture toughness, and then there are certain toughening mechanisms that are there or that come into picture on the addition of the fibrous reinforcement. Now, what are the different types of toughening mechanisms, that also we have seen. If you remember, in lecture 2 we have seen that there is crack impeding as one of the toughening mechanism. Then there is a deflection of the crack or the fiber or the whisker pull out. So, there are different types of toughening mechanisms that come into picture when the ceramic matrix is reinforced with the fibrous reinforcement. So, we ended our lecture 2 in this particular module of ceramic matrix composites with the toughening mechanisms. So, already we have taken 2 lectures or we have discussed 2 important aspects of ceramic matrix composites, that is the fundamentals, that is what is the need to develop a ceramic matrix composites from a ceramic matrix, and the mechanical properties of the ceramic matrix composites. As our focus primarily is on the processing aspects of non-metals, so from now on we would be discussing the various techniques which are used for processing of ceramic matrix composites. As the title of the today's lecture go, that is the powder processing. So, we will see that how the powders of the various constituents of the composite would be combined together, or what are the steps involved in combining the matrix and the reinforcement which is available in the form of powder, and how we can make a product by combining the matrix and the reinforcing fibers. The reinforcements can be in terms of, we can say, particulates also, particles can also be there, short fibers can be there, whiskers can be there, and we will see what precautions we should take when we are using the fibers as the reinforcing agent or the reinforcing phase. So, in today's lecture our first focus would be to highlight the various types of processing techniques or processing approaches which are used for ceramic matrix composites, and then we will see that what are the important challenges for processing of ceramic matrix composites, and finally we will see the basic technique of powder processing. In our subsequent lectures our focus would be on other processing techniques of ceramic matrix composites such as chemical vapor infiltration or impregnation, and certain other techniques such as sol gel process. So, let us start with our discussion with the introduction which I have already given. First and foremost, I want to address an important point, that is the challenges for CMCs. So, the challenges for CMCs basically are a hindrance to the widespread application of ceramic matrix composites. Now, what are the challenges? Point by point we would try to address this important issue. First important point on your screen, I will read it for you. Processing routes for ceramic matrix composites involve high temperatures. So, the techniques that we are going to use, in certain techniques we would be doing sintering, or in other technique other high temperature other types of high temperatures would be required to fabricate the CMC product. So, the processing routes for CMCs involve high temperature. So, whatever techniques we will see in one form or the other, at one stage or at the another stage, or at one phase or at the another phase, high temperatures would be involved. So, the first and the foremost point is the processing routes for CMCs involve high temperature. So, only it can be employed with high temperature reinforcements. So, as you know, we have already been discussing the concept of the composite material, but for the audience who are only viewing this particular lecture, let me again revise that what is the basic concept of a composite. In a composite, we have a matrix and a reinforcement. So, there are two macro constituents which are combined together to make a composite material. So, in case of ceramic matrix composites, our matrix is made up of a ceramic material, and all of us know that ceramic has high temperature applications. So, it is used for high temperature application. So, important point is the matrix can bear the high temperatures of processing, but the reinforcement that we are adding in the matrix should also have this high temperature resistant property. That is, it should be able to bear the high temperatures of processing. So, if the matrix can bear the high temperature of processing, the reinforcement can also bear the high temperature of processing, we can combine the matrix and the reinforcement together at a elevated temperature and can get a final product which is a ceramic matrix composite. But suppose we are using any metal as a or any metal fiber as a reinforcement material. So, it will have an intermediate temperature, whereas the ceramic matrix can bear a very high temperature. So, the matrix can bear a high temperature, but the reinforcement cannot bear a high temperature, and therefore, the processing will become difficult. So, one of the important challenge for processing of ceramic matrix composite is that both the constituents which are going into the composite should have high temperature capability. So, the first point has been addressed, that is processing routes for CMCs involve high temperature. So, all the processes that we are going to see or that we are going to discuss in this particular module will involve high temperature at one stage or the other, which has already been highlighted. So, the processing techniques can only be employed for those constituents which can bear the high temperature. So, all of us know ceramics can bear, but the reinforcement should also have this capability to bear the high temperature, and then only the reinforcement and the matrix can be combined together to make a composite. And the composite in question in today's lecture is the ceramic matrix composite. The second issue, the high temperature properties of the reinforcement are also important during service. So, why this is important? Because if you remember, we have seen that ceramics are often used for high temperature applications. Similarly, the ceramic matrix composites are also designed and developed for high temperature application. So, no doubt the ceramic or the matrix can bear the high temperature in service, but the reinforcement should also be able to bear the high temperature in service. So, if the reinforcement is not able to bear that high temperature, the product which has been made out of a ceramic matrix composite will fail. So, that is an important issue which limits the application of certain ceramic matrix composites, because the reinforcement is not able to bear the high temperatures in service. Third important point from the processing point of view is the difference in the coefficients of thermal expansion between the matrix and the reinforcement. So, this is true in case of polymer matrix composites also, where we use the reinforcement in terms of fibers such as the carbon fiber, the glass fiber or the aramid fiber. So, the matrix is a polymer, either it can be a thermoset or a thermoplastic, the reinforcement is a fiber, and there is a difference between the properties of the matrix and the reinforcement. Similarly, in case of ceramic matrix composites also, there is a difference between the properties of the matrix and the reinforcement, and one of the important property is the coefficient of thermal expansion. So, there is a difference between the coefficients of thermal expansion between the matrix and the reinforcement, and this difference may lead to the thermal stresses when these thermal stresses would develop on cooling from the processing temperature. So, as we have already seen in point number 1 that the processing temperature in most of the processes that are used for processing of ceramic matrix composites are extremely high or on the higher side. So, from those processing temperatures, when the ceramic matrix composite will come to the room temperature, thermal stresses would be developed in the composites on account of the difference between the coefficients of thermal expansion of the matrix and the reinforcement. So, therefore, this important point has also to be taken care of when we are processing the ceramic matrix composite. So, there are issues and challenges involved in processing of ceramic matrix composite, and because of these issues and challenges, we are not seeing many applications of the ceramic matrix composites, although there are applications, but as compared to the other counterparts, that is the polymer matrix composite and the metal matrix composite, the application spectrum of ceramic matrix composite is limited. So, these are some of the challenges which engineer should keep in mind when he is going to process the ceramic matrix composite with one or the other route. Although we are going to discuss number of processing routes for ceramic matrix composites in our subsequent lecture, and today we are going to focus on the powder processing technique for processing of ceramic matrix composites. So, let us now see that what are the important techniques which are used or the important approaches that are used for processing of ceramic matrix composites. So, on your screen you can see processing approaches for ceramic matrix composite. The first approach is the powder processing, in which we do the hot or cold pressing of the ceramic powders mixed with the reinforcement. So, we can do consolidation of the green fabricated, we can say, raw material which has been fabricated by the addition of the reinforcement and the matrix material. So, we will see in detail with the help of a flow chart that what are the various steps involved in powder processing. So, one of the processing approach for processing of ceramic matrix composites is the powder processing. It can be hot and cold, it involves hot and cold pressing. Next technique on your screen is a slurry infiltration or impregnation. So, that is also an important technique which is used for processing of ceramic matrix composites, and we will see in our subsequent lecture the process details of this technique. Polymer infiltration and pyrolysis is another technique which is used, which is developed. Chemical vapor infiltration or impregnation, which I have already told in today's lecture that there are number of techniques which are used, and chemical vapor infiltration, which is we can say a subset of CVD process, that is chemical vapor deposition process. So, from there we have got this chemical vapor infiltration process which is specifically used in case of ceramic matrix composites. Then there can be reaction bonding processes, and finally the directed oxidation. So, there are number of techniques which have been well developed or are in the stage of development into commercialization, which have been used for processing of ceramic matrix composites. So, we will try to see that what are the various process details and what are the various application areas of these processes in our subsequent lectures. But once a ceramic matrix composite product has been made by any of these processes, it has to be post processed, because in many cases we require our product to perform a certain function. It has to have a particular surface finish, it has to has a particular functionality. Sometimes we may be requiring to finish or to, we can say, glaze the product. Sometimes we may require to machine the product which has been made by the ceramic matrix composite. So these are the processes which will give us the product, that is the ceramic matrix composite. But finally we have to do some post processing on this particular product for certain specific applications. So why post processing is required, that we are going to see in the subsequent slide. So on your screen you can see there are few points for post processing or in favor of post processing. So previous slide we have seen that what are the important techniques which are used for processing of ceramic composites or ceramic matrix composites. Now we will see the post processing of ceramic matrix composites. This point I have already highlighted in the fundamental aspects in lecture number 1 in ceramic matrix composites, in which we have seen that why or what is the need of development of ceramic matrix composites, and we have seen that where the ceramic matrix composites fall in the broader picture of the composites family. There also we have seen that what are the major type of processing techniques and what are the post processing requirements of ceramic composites. So again I am highlighting the important point, because today we are going to start the discussion regarding the processing techniques of ceramic matrix composites. So on your screen you can see that why post processing of ceramic composites is required. So there are 4 important points which necessitates the post processing of ceramic composite. First and foremost is the finish requirements, and in finish we can undergo or we can undertake the process of grinding. So in sometimes in certain application we require a very high surface finish of the product. So for finishing, grinding is one of the most commonly used process. So first and foremost post processing is in terms of finishing. Second, post processing is in terms of functionality. Sometimes these ceramics, all of us know that they are porous in nature. So that important, we can say, property of porosity is sometimes utilized for making, suppose, self lubricating bearings, in which the oil or the lubricating oil would be pre-impregnated in the bearing, and then when the bearing will be in use, the oil would be coming out from the pores of the bearing. So maybe sometimes the functionality such as lubrication has to be incorporated in the ceramic product or the ceramic matrix composite product, and for that particular application we may be requiring some post processing, like dipping it in a oil for a specific period of time, so that the oil by capillary action or by any other action seeps into the pores and it is stored in the pores, and when in use it comes out for the purpose of lubrication. So the functionality of the ceramic matrix composite has to be improved, and therefore post processing becomes inevitable. Also sometimes to enhance the properties also post processing is required, such as we require a very high hardness on the outer shell. So for that sometimes the post processing treatment may be required to improve the hardness on the outer periphery of the CMC or ceramic matrix composite product. So for that also sometimes some certain processes or operations will be done after making the CMC product, and the final result would be that we would be getting enhanced hardness or increased hardness at the outer shell or the outer periphery of the CMC product. And finally, which is the most important buzzword or the catchword, is the aesthetics, that is the product should be pleasing to the eye. And the CMC product that we are making by any of the processes which we have seen in the previous slide, whatever product we get, we sometimes would require to make it more we can say pleasing to the eye, or it to be making it more presentable, and for that sometimes one of the operations can be glazing, and there can be other operations which can be done in order to improve the looks of the CMC product. So we have seen till now that what are the different types of processes which can be used for fabrication of or processing of ceramic matrix composite products. And also we have seen that once the product is ready, we need to do some post processing on ceramic composites on account of the finish requirements, or to enhance the functionality of the product, or to enhance the properties such as hardness, and finally to make it pleasing to the eye, or to improve the aesthetic aspects of the ceramic matrix composite product. So processing is also important, and the post processing is equally important to improve or increase the application spectrum of the ceramic matrix composite products. So that is important. Now we will see that what are the challenges. Now it is easier said than done. We have already seen in slide number 1 today that there are challenges for processing of ceramic composites. We have seen the high temperature applications, the temperature at which the reinforcement can sustain or can retain its properties is equally important. Matrix, no doubt, ceramic, it has the capability to bear high temperature, but the reinforcement that we are putting in the ceramic matrix to make a ceramic matrix composite should also have the similar types of properties at elevated temperature. Then only the product would be able to serve the purpose. So there are challenges, and there can be certain other challenges which may be taken into account when we are talking about the processing aspects of ceramic matrix composites. So we can also see that there are certain problems like the ceramics are brittle in nature, they have very high hardness, and this leads to the processing difficulties. So one important processing difficulty was the difference in the properties of the reinforcement and the matrix. One of the important points we have seen the difference in the coefficients of thermal expansion, which may lead to the thermal stresses being developed during the processing. So the difference in the properties of the matrix and the constituent, then the brittle nature of the ceramic matrix as well as the high hardness of the ceramic matrix often lead to certain processing difficulties, and therefore the conventional methods of converting the raw material into the final product are not advisable for processing of ceramic matrix composites, and therefore different types of approaches are developed or are in the process of development for fabrication of products made by the ceramic matrix composite. And on your screen you can see the problem areas associated with the fabrication of CMC product has led to the development of unconventional processing techniques. So we are going away from the conventional techniques towards the unconventional techniques for processing of ceramic matrix composite. So once again, to revise that what are the major challenges in fabrication of ceramic matrix composite, major challenges are the difference in the properties of the matrix and the reinforcement, the brittle nature of the ceramic matrix, and a very high hardness of the matrix and the reinforcement. So these are important challenges which have to be taken into account when we discuss the processing techniques for ceramic matrix composites. Now we come on to the one of the basic techniques of fabrication of ceramic matrix composite products. So let us see the introductory part of powder processing. It is a fairly simple method, but there are many challenges involved in powder processing that we would be covering in the subsequent slide. So we will see that what is the process, what are the various steps involved in the process, and finally we will see that what are the limitations or the challenges which have to be taken into account when we are going to make a product by the powder processing technique for ceramic matrix composites. Let us see the basics of the process. This is generally used to fabricate discontinuously reinforced ceramic matrix composites. So if you remember, we have seen in case of ceramic matrix composite, the matrix is a ceramic and the reinforcement can have three subcategories, that is based on the shape of the reinforcement, based on the orientation of the reinforcement, and finally based on the chemical nature of the reinforcement. There can be three subcategories of the reinforcement, and according to the shape of the reinforcement we can have particles in the reinforcement, we can have short fibers, and we can have long or continuous fibers, as well as we can have whiskers as the reinforcement. So this particular process that is the powder processing, is generally used to fabricate discontinuously reinforced ceramic matrix composite. So, discontinuously reinforced means that in this particular technique we will not be using long fibers as the reinforcing phase or the reinforcement agent. We would be using small fibers or whiskers or the particles in the reinforcement phase, or the reinforcing material would be short fibers, whiskers or particles. Long fibers will not be used. This is one important aspect which should be taken into account. Second, the process is only efficient for very small reinforcements such as whiskers and particulates, which I have already explained in point number 1, that this particular technique is specifically suitable for short reinforcements. So, short reinforcement or small reinforcement such as the whiskers and the particulates. Even for whiskers and particulates there are certain issues which have to be addressed and which we would be covering when we will see that what are the challenges for processing by powder processing techniques. We will see that what are the issues involved in whiskers and particulates. Next stage is the mixing and consolidation processes may break the long discontinuous fibers. Even in discontinuous fibers also we will not go for fairly long fibers. Although we are not using continuous fibers, we are using discontinuous short fibers only, but the length of the fibers is also important. If the length is considerably long or long fibers are there, then this process of mixing and consolidation may break the fibers or the whiskers. So, therefore, we should limit the length of the fibers that we are putting in the ceramic matrix as the reinforcement. Next point, voids content can be minimized through uniform dispersion of the reinforcement and the matrix. So, there are chances of agglomeration of the reinforcement. Sometimes some bundles of reinforcement or the bundles of fibers may form within the bulk of the matrix. So, that has to be avoided because we want a uniform distribution of the reinforcement in the ceramic matrix. Then only we will be able to achieve good properties or excellent mechanical properties. If we have the concentration of the reinforcement at a particular location, so it will act as an inclusion, and when this particular CMC product would be loaded, there are chances that because of stress concentration at certain locations the product may fail. So, the prime objective of the mechanical engineer or the engineer who is involved in processing of ceramic matrix composites is that he has to ensure the uniform distribution of the reinforcement in the ceramic matrix. So, again I am emphasizing the last point on your screen, that is the void contents can be minimized. We do not want any voids. Certain times we adequately require a porosity, sometimes the porosity may be required, but although it may be required in certain cases, but in many cases it may not be required also. So, depending upon the application, if we want to avoid the voids, then void content can be minimized through uniform dispersion of the reinforcement and the matrix. So, when we are mixing the reinforcement and the matrix, we should ensure a uniform dispersion, and then only we would be able to achieve the mechanical properties. Moving forward from the last point, on your screen you can see optimum packing can be achieved. Now, we want a optimum packing, we want a dense product. So, optimum packing can be achieved when the particle size distribution contains 25 to 35% by volume of small particles and 65 to 75% volume of large particles. Now, let us take an example. When we are mixing the reinforcement with the ceramic matrix, if all the reinforcing particles are of same size, suppose we take on an exaggerated scale, we take that all the reinforcement particles are like tennis balls. So, all the balls are of same size, we will not get optimum packing. But if we have the distribution in the particle size, we have a particle size distribution that few particles are of small size, There are other particles which are of medium size, and there are few particles of large size. We can expect a optimum packing. So which means that with tennis balls we can have few table tennis balls also, and we can have few marbles also. So when we pack the tennis balls, the table tennis balls and the marbles together, we can expect a optimum packing of the particles. So this particular point highlights, because in our previous slide we have seen that we want a uniform dispersion of the ceramic matrix particle and the reinforcing particle. So optimum packing is our desirable characteristics. So optimum packing can be achieved when the particle size distribution contains a well distributed particle size, that is, some particles may be from 25 to 35% by volume are small in size, 65 to 75% particles are large particles. So we will get a optimum packing of the particles and we will get a fairly dense product. Addition of whiskers to a slurry can result in undesirable increase in the viscosity, which is another point which has to be taken into account. So the viscosity of the slurry has to be maintained. So that is another issue which has to be taken up when we are processing the composite product. So there are few points which have to be taken into account, and if all these things are taken into account at a initial stage of the processing and all the important characteristics or important requirements are optimized, we would be able to get a very good quality ceramic matrix composite product. So now let us see the process details of the powder processing, that what are the important steps involved in powder processing. So on your screen you can see these are the basic and the fundamental aspects. There can be few additional steps also which may be present or which may be required to get certain specific requirements or certain specific features in the final product, because whatever final ceramic matrix composite product we want to form, it may be designed for certain specific application, and there would be certain design requirements which have to be met at the processing stage only, but the fundamental steps would remain same, and our focus is to understand these fundamental aspects only. So let us see that what are the fundamental aspects of powder processing. So first and foremost we have to undertake the mixing of raw materials. Now what are the raw materials that are going into the final product? There are two. One is the matrix, another is the reinforcement. So matrix in this case would certainly be a ceramic matrix. The reinforcement can be any other type. So we have a ceramic matrix and a reinforcement. The reinforcement has to be in the form of, as we have already seen, that we are not going to use long fibers in case of powder processing. So we are going to have reinforcement in the form of short whiskers or very small particles. So mixing of the raw material, that is the ceramic matrix and the reinforcement together. So we can get these powders by different processes, like ball milling can be one of the processes for getting the uniform distribution of the particles. So we can get the powders from ball milling, but once we have got the ceramic powder as well as the reinforcement, we will mix the two things together. So first important step is the mixing of the raw materials. So once they have been mixed together, we have to avoid the accumulation or the agglomeration of one particular or the reinforcement phase, because it has the tendency to form bundles or to form the agglomerate. So that has to be ensured that the reinforcement is uniformly spread in the matrix. So that is one important point to be taken care of in the very first step of the powder processing technique. So first step is to ensure a uniform mixing of the raw material. Second is the green body fabrication, and it can be achieved by cold pressing or injection molding. So green body means that it is the initial step, as we see in case of casting we say green sand mold. So similar analogy can be drawn here also, the green body fabrication. There can be binders also which are added during the mixing of the raw material. So these binders will give a particular shape to the product. So here we will do the green body fabrication. It can be done by cold pressing without any temperature or by the injection molding. There can be other processes also which can be used for green body fabrication. So we have mixed the raw material and we have ensured the uniform mixing of the reinforcement or the uniform distribution of the reinforcement in the ceramic matrix. Next stage is the green body fabrication. Two processes are there on the screen. There can be other processes also which can be used for the formation of the green body. Then we give a particular shape to the green body by machining, or certain times we may not require machining. Within a mold also we can try to give a shape to the green body. Once the green body has been fabricated, we know the shape, whatever shape that we want to make. Finally, we want to do the consolidation and the densification. So we want a dense CMC product, and for that we need to do the consolidation. How it is done? It can be done by sintering. Sintering can be done at an with the help of pressure or without the pressure. In many cases it has been seen in the formation or powder processing of monolithic ceramics that sintering can be done without the application of pressure, but in many cases with the application or with the incorporation of the reinforcements, certain times the sintering without pressure becomes difficult. Again I am going to tell this important aspect that in monolithic ceramics, when we are forming the ceramic products, sintering can be done without the application of pressure, but when the reinforcement is added into the ceramic matrix and we are going to make a ceramic matrix composite in which we have the reinforcement in terms of whiskers or small fibers or small particles, in that case sometimes the sintering, to achieve sintering process without the application of pressure is difficult, but it is not unachievable. It can be done, but with under certain specific requirement, and in many cases the pressure would be required. So pressure can be applied as the other two processes you can see in this particular step of consolidation and densification. The hot pressing can be done or the hot isostatic pressing can be done. In hot pressing we apply pressure also, and in hot isostatic pressing again the pressure is applied. But this hot pressing and hot isostatic pressing, when we are applying the pressure on the ceramic matrix and the reinforcing or on the green body, it has got its own challenges, because in hot pressing also there are challenges and we need to have a press for that. We need to have a press of very high tonnage. And in case of hot isostatic pressing, it is expensive process. So if we want to make products which are to be sold in non-structural applications or which are not for very high end applications, and if the products are to be sold in consumer market and the cost is an important criteria, we will not like to have a expensive equipment for the formation of CMCs. So hot isostatic pressing, one of the challenge, there can be other challenges also, is that it is an expensive process. So hot isostatic pressing is a difficult, or not a difficult but an expensive process, and hot pressing we require a press of a high tonnage. So both hot pressing and hot isostatic pressing has got its own limitations. And finally the inspection has to be carried out. So we have to have adequate consolidation, adequate density, and sometimes we may be requiring porosity in our final product. So that has to be checked by different techniques, whether the product which has been formed is porous or not, or what is the degree of porosity in the final product. So the basic steps involved are, without going into the details of the various steps, I would just like to revise that what are the various steps involved in the powder processing. First step is the mixing of the raw materials. In this particular stage we have to ensure the uniform dispersion of the reinforcement and the matrix, that is the ceramic and the reinforcing agents. Second is the green body fabrication, that is giving shape or forming the ceramic matrix composite product. That forming can be achieved by cold pressing or injection molding. Next is certain times machining may be required or may not be required. And finally the consolidation and densification, which in case of ceramic matrix composites may require pressure also. So we may go for hot pressing or we may go for hot isostatic pressing, but both hot pressing and the hot isostatic pressing have got their own challenges, but certainly if we will use these processes we can get the adequate amount of consolidation and densification. And finally, once the product is ready, the last stage is the inspection of the formed product. So these are the basic steps involved in the powder processing of ceramic matrix composite products, but there are many challenges involved. So we will try to highlight that what are the challenges, because looking at the steps involved it seems that it is a very simple process and it can be achieved. A good quality product of ceramic matrix composites can easily be got or easily be fabricated, but there are challenges involved. Now one by one we will try to address these challenges. Now what are the challenges in powder processing? First important challenge is the homogeneous mixture of the constituents cannot be achieved readily. So the first step also I have told maybe 2 or 3 times that we have to ensure a homogeneous mixture or a uniform dispersion of the matrix and the reinforcement. So it is sometimes difficult to achieve. Why? Because the reinforcement has the tendency to form agglomerates, and agglomeration is a big issue or a big problem. Sometimes fiber bundles are also noted, so that has to be, we have to minimize that effect. So we have to avoid these agglomerates and fiber bundles during the mixing stage. So first important challenge is we have to ensure the homogeneous mixture of the constituents. Second, high proportion of the toughening phase cannot easily be achieved. So the volume fraction, or we can say by volume, the toughening phase. Now what is the toughening phase? Toughening phase is the reinforcement. So it is difficult to achieve a very high proportions of the reinforcement in the ceramic matrix composite. So that is also an issue. Next challenge, mixing and pressing operations causes damage to the whiskers. In specific case where the reinforcement is in the form of whiskers, it has been noted that the mixing and pressing operation sometimes causes damage to the whiskers, and when the whiskers are damaged or the reinforcement is damaged, it would certainly affect the mechanical properties of the product which has been achieved or which has been processed with the whiskers as the reinforcement. So the whisker reinforced ceramic matrix products may certain times have certain we can say deteriorated mechanical properties because of this particular processing difficulty, that is the damage to the whiskers which has taken place during the processing. Next is the reduced packing efficiency. So that is another challenge, that the packing efficiency sometimes is less in case when we are processing the product by the powder processing technique. The other challenges in powder processing are fibers and whiskers can form a network that may inhibit the sintering process. So that is another challenge which we have already seen, that agglomeration or fiber bundles may be formed during the process of mixing. So that have to be avoided, and if these bundles are formed or they are a network of the fibers and whiskers are formed, the sintering process becomes difficult. So if the sintering is not done properly, we will not get proper consolidation and densification, and because of improper densification and consolidation, the product that we are getting may not be able to achieve the target or the design requirements for which it has been fabricated. The next stage is the next challenge is the hydrostatic tensile stress may be developed due to difference in the coefficients of thermal expansion of the reinforcement and the matrix. So that we have already seen that because of the difference in the very beginning, in today's lecture, in the very first slide we have seen that there is a difference in the properties of the reinforcement and the matrix, and this difference may lead to certain type of stresses that are developed during the processing. So in this particular point, as one of the challenges, it is seen that the tensile stresses are developed due to the difference in the coefficient of thermal expansions of the reinforcement and the matrix, and which may later on the when we are going to use this product for a particular application, these particular stresses may lead to the failure of the product. So these type of stresses have to be avoided. So the important point to note is that we have to take care of the difference in the properties of the reinforcement and the matrix. So we have seen that although the process of powder processing seems very simple, but there are many challenges in the process which have to be taken care of in order to make a good quality product by powder processing. So with this we come to the end of this lecture number 3 in module 6 of our course on processing of non-metals. In module 6 our focus is on processing of ceramic matrix composite products, and we have already seen the fundamentals of the ceramic matrix composites, and today we have seen one of the important techniques of making the ceramic matrix composites, that is the powder processing. We have seen the basic steps involved in the powder processing and the important challenges that are present in the powder processing technique. With this we come to the end of today's lecture, and in the next lecture we would be focusing on certain other techniques of processing of ceramic matrix composites. Thank you.